Okay, this video is for the second part of section 3.4. I've got the properties of logarithms up here. Most of these we've talked about already. This is the fundamental definition of a logarithm. This is the exponent becoming a coefficient. This is the sum becoming a product and the difference becoming a quotient. This last one we haven't talked about yet. It's pretty straightforward. It says that if you have two logarithms with the same base that are equal to each other, then what are called, people sometimes call these the arguments, the m and the n. That means that m and n have to be equal to each other. Why? Well, if you say, let's say log to the base b of m is equal to x. So if these two things are equal to each other, then log to the base b of n is also equal to some number x. This says b to the x equals m. This says b to the x equals n. Well, if they're both equal to b to the x, then m and n have to be the same number. Okay? If the logarithms are the same, then the numbers themselves also have to be the same. And we'll use that in solving some of these equations in section 3.4. Okay, so let's start out with some simple problems. These start on page 173, and they go over onto page 174. So we'll start with problem 16, which says ln x plus ln 4 equals ln 2. Okay, so first we'll use this property right here, and we'll rewrite this sum of logarithms as the logarithm to the base e, or ln of 4x, equals ln 2. And now we pull these out and set them equal to each other. That means 4x must be equal to 2, and x is equal to 1/2. Okay, like I said, it's a pretty simple problem here, just kind of getting used to these ideas. Let's see, problem 18. We've got log to the base 10 of 2 minus log to the base 10 of x equals log to the base 10 of 8. Alrighty, let's see here. So we can rewrite this as log of 2 over x equals the log of 8. And then we'll pick these out and set them equal to each other. So we'll multiply on both sides by x. So 8x is 2, and x is 1/4, or 0.25. All right, let's look at some a little bit more complex problems here over on page 174. Let's see here. Problem 20. Says log to the base 6 of 2 minus log to the base 6 of x minus 2 equals log to the base 6 of 9. Alright, so now we'll use this property right here, and we'll rewrite this as log to the base 6 of 2 over x minus 2 equals log to the base 6 of 9. Then we pull these out, set them equal to each other. 2 over x minus 2 equal to 9. Multiply on both sides by x minus 2. So 2 is 9x minus 18. 9x is 20. And x is 20 over 9. If you don't like fractions, you can call this, what is this going to be? 2.2 repeating. That's also fine. Okay. Let's keep going here. Problem 22. We've got log to the base 9 of 2x plus 7 minus log to the base 9 of x minus 1 equals log to the base 9 of x minus 7. Okay, so again, we're going to use this property right here. We'll rewrite this as log to the base 9 of 2x plus 7 over x minus 1 equals log to the base 9 of x minus 7. And then again, pull these out and set them equal to each other. And then we want to clear out this denominator. So multiply on both sides by x minus 1. Those cancel out. And so we get 2x plus 7 equals x squared minus 8x plus 7. So we'll move everything over to one side. And we get 0 equals x squared minus 10x. You can run this through the quadratic if you want to. A is 1, b is negative 10, c is 0. You can also solve this by factoring. And so we get x equals 0 or x equals 10. All right. We'll look at a couple more here. Problem 24. So 24 and 26 are a little bit different. 24 says 2 log to the base 4 of y equals log to the base 4 of y plus 2. Now, in this problem, one thing I want to call your attention to is that all of these properties here, there's always a 1 in front of the logarithm. The only place where that's not true is right here. Okay? If you've got a coefficient in front of your logarithm, one way to work with that is to move that up as an exponent. And so we're going to restate this as log to the base 4 of y squared equals log to the base 4 of y plus 2. So now we've got it set up like this, and we can pull these out and set them equal to each other. Y squared equals y plus 2. And you can run this through the quadratic if you'd like to. It's also factorable. And so we get answers of y equals 2 or y equals negative 1. All right. There's just one more to look at here. Problem 26. Let's see here. 26. 2 log to the base 5 of 7 minus log to the base 5 of x plus 1 equals log to the base 5 of 2x minus 5. Okay, so again, we've got the same issue here in this problem as we did in the last one. So we want to rewrite this as log to the base 5 of 7 squared, and then minus log to the base 5 of x plus 1 equals log to the base 5 of 2x minus 5. So now we're going to rewrite this using this property right here. So this will be log to the base 5 of, that's 7 squared is 49, over x plus 1 equals log to the base 5 of 2x minus 5. And now we can use this property right here and say 49 over x plus 1 equals 2x minus 5. And then we'll multiply on both sides by x plus 1. Those cancel. 49 is equal to, let's see, 2x squared minus 5x plus 2x, so that's minus 3x minus 5. Move the 49 over here. And so now we get 2x squared minus 3x minus 54. Okay, this one is factorable, but it's a little bit tricky. So we can just run this through the quadratic. And so we'll put in 2 minus 3 and minus 54. And we get x is equal to 6 and negative 4.5. And if you want to remember, we talked about how to build factors from roots. So if we have x equals 6, that means x minus 6 is a factor. X equals negative 9 over 2, that's negative 4.5. So 2x is negative 9, and 2x plus 9 is the other factor. So you can actually use the roots to help you to factor a polynomial. That's part of what we were doing in Chapter 2. You don't need to worry about this at all. I just wanted to show you how what we did in Chapter 2 relates to this issue right here. But the answers are 6 and negative 4.5. So that's it for section 3.4. Yeah. And that's the last section we're going to do. There's one more section in the textbook, but because we're a week short on the spring term, we only had 9 weeks instead of 10 weeks, we're not going to cover that section. Okay? So this is it for the content. You'll have a quiz that goes along with this, and that'll be due on Wednesday, June 3rd, which is also when your second project is due. And so on the 3rd, I will be sending out the take-home final, and as always, and then the final is going to be due on Wednesday, June 10th, during finals week, and that'll give me time to collect all of the take-home finals and to get those graded in time to turn in my grades. All right, as always, if you have any questions, please let me know. Be happy to talk with you. Or email with you. You can also contact Kelly Musgrove in the math lab. She's running a virtual math lab this term, and if you have any questions, either one of us would be happy to talk with you about it. So until then.